This is part 2 of our main topic, causes of weather. Unequal heating of the Earth's surface causes differences in pressure and altimeter settings. Unequal heating of the Earth's surface causes differences in pressure. Let's leave it right here. And I'm going to be talking about these two drawings up here. So here you can see grass, air molecules, and a bit of clouds. Yeah. So look at these air molecules. They're all packed. They're all close to each other. And these air molecules are pressing down to the ground. And that's called high pressure. More air molecules pressing downward. So again, these are cool air molecules and they're all packed and they're pretty much exerting a pressure in the Earth's surface. Now look at the air molecules here. It's hot, the sun is right here. And look what happened to the air molecules. They're spread apart and they're moving upward. And that is called low pressure. Why? Because look at the air molecules, they're not pressing downward anymore because of the heat. Look at the air molecules. They're moving upward. Air molecules rise due to heat. So there's less pressure being exerted in the Earth's surface. So we can tell the difference from these air molecules, all packed, pressing downward, and these air molecules that are spread and they are moving upward. Let's take a look at these two illustrations down here with the airplanes. And before I continue, I'm going to give you guys an example which is very simple, and it might not contain the proper aviation terminology, but it is just so you guys can understand what's going on with the altimeter when it is exposed to unequal heating. So in this first quadrant, we have an airplane. It's taking off, and look at the air molecules below it. They're all packed, and as a plane keeps climbing, there are more air molecules below the airplane. So the airplane starts flying from here to here. This column right here is going to be full of air molecules, and the altimeter is counting all the air molecules, and it's turning it into altitude. So from here would be, just as an example, right? 50 feet, 100 feet, 150 feet, 200 feet, 250 feet, 300 feet, 350 feet, and so on, so on. The number keeps growing because of the amount of air molecules, right? So the altimeter, it's pretty much reading the air molecules, and then it translates it into altitude. So pretty much by using the altimeter, we, the pilots, we can tell that we're climbing. So this is one example. Now in the second example, it is sunny, it is a warm day, and look at the air molecules. They're spread from each other, they are apart from each other, and what's going to happen with the altimeter is that it's going to confuse the altimeter. It is going to be hard for the altimeter to tell exactly at what altitude it's climbing. Why? Because it cannot count the air molecules below it. Because look at the air molecules. I give you an example here, right? Just a simple example. The more air molecules below me, the higher I'm climbing. And I can tell because the air molecules are stacked, one on top of each other. But here, how is a plane able to tell if it's climbing at the proper altitude? What the altimeter is going to think, it says, there's low pressure, I must be flying high. So there is low pressure because look at the air molecules, we talked about it. There is less weight being exerted in the ground because the air molecules are moving upward because of the heat. And it's the same thing here. There is less force being exerted in the ground and the Earth's surface because the sun is warming up the air molecules and they're moving upward. So the plane, yeah, you're flying the plane, you can tell you're climbing, but can you tell me like what number, what's the altitude? If I'm flying 2,000 feet, 3,000 feet, 4,000 feet, it is going to confuse the altimeter because it cannot count the air molecules below it. because look, they're all around the space, so it cannot tell. So again, I mentioned it before, but it's just a simple example of what the altimeter thinks. So in this case, the altimeter is a bit confused, and it's thinking there's low pressure. Yep, there's definitely low pressure, so I must be flying high. And the problem is, it's going to be in the altimeter. When you read it, it is not going to show you the proper altitude. So yeah, this is a proper example, and this one is a simple example, so you can understand what's going on with the altimeter settings.